In this lesson, we are going to be covering sine, cosine, and tangent, which you learned last year, as well as 3 other trig functions. So before we begin, we're just going to review some formulas. First is the Pythagorean theorem, a squared plus b squared equals c squared. And this can only be used with right triangles. And the main time we use this is when we have 2 sides, it could be any of these, and we want to find a third side. Remember, the hypotenuse has to go in for c. The 3 trig functions you already know are sine, cosine, and tangent. A memory device for them is SOHCAHTOA. So we write fractions here. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So we see that listed here. Sine of A is the opposite side over the hypotenuse. If you want to pause and read over those a little bit more, that's fine, but I'm going to move right down to the problems now. So let's just move down. So in each of these problems, it says find the trigonometric functions with the given information. I'm just going to try to zoom in a little bit without making it sideways. Yeah, it's not too bad. Okay, so here we have DE is 1. So DE is 1, so I will label side DE 1. DF is 3. And we want to find the sine of f, the cosine of f, and the tangent of f. Now, in order to do so, we do need to find this third side for most of them. So this is where the Pythagorean theorem comes in. So I'm going to write a squared plus b squared equals c squared. The 3 needs to go in for c because it's the hypotenuse. My missing side I'm going to label as x. And really, I can use the 1 and the x interchangeably, so I'm just going to write 1 squared plus x squared equals 3 squared. So from here, I'm going to subtract the 1, and I get x squared equals 9 minus 1, which is 8. And then to solve next, we'll take a square root. So I get x equals, and to simplify this, that's 4 times 2. So x is going to equal 2 radical 2. Technically, this is plus or minus 2 radical 2 from what we've learned earlier in the year, but since this is a triangle, I do not need to consider the negative answer. So this side is 2 radical 2. My first trig function I'm going to find is the sine of f. Now, we always want to circle the angle we're working from. So since I said sine of f, I'm circling this angle. We're going to label opposite, adjacent, and hypotenuse. The easiest is hypotenuse, so I'm just going to put an h here. Remember, the hypotenuse is across from the right angle. Opposite is opposite angle f, so I'm ignoring this other little arrow. So we're going opposite angle f, so this is opposite. And then the remaining one is adjacent. Adjacent means next to, and it's the one next to the angle that's not the hypotenuse. So looking at sine of f, I'm just going to erase that so it doesn't look like sine of e. So looking at sine of f, we want opposite over hypotenuse. So my opposite side is 1, and my hypotenuse is 3. So we'll write that down, 1 over 3. The cosine of f, we want adjacent over hypotenuse. So the adjacent side is 2 radical 2. The hypotenuse is 3. And lastly, the tangent of f, which is opposite over adjacent, so I have 1 over 2 radical 2. Now in this problem, we have to consider the fact that there's a radical in the denominator. We need to do something called rationalizing the denominator, which means we need to get rid of that radical, and what we do is no matter what the radical is, I'm going to multiply by that radical over itself. This doesn't change the value of my fraction, it's basically multiplying by 1. When I multiply my numerators across, I get 1 radical 2, which is just radical 2. Here, I get 2 times 2 because a radical times itself is that number. So these 2 make a regular 2. 2 times 2 is 4. So that's our final answer for tangent of f. Remember, since this 2 is in a radical, it doesn't cancel with the 4, even though it kind of looks like you can. We can only cancel if things are outside of radicals or both inside radicals. So moving to the bottom problem, I'm actually going to have you guys try this one, and then I'll come back and do the work. So pause the video and come back. I'll have some answers up and we'll look at it. So I am going to do all of the angles related to angle x first, or all of the trig functions related to angle x. Notice I circled angle x here. I labeled my opposite, adjacent, and hypotenuse. In each of these fractions, I have numbers that will reduce. So for example, when I did opposite over hypotenuse for sine, 5 and 10 are both outside the radical. There's no addition in this fraction, so this is a legal move, so I reduced them to 2 over 1, which is radical 3 over 2. Using the same reasoning, I reduced the cosine x and tangent x values. So I'm going to pause the video and put up the y answers. You're going to notice that my opposite and adjacent are going to switch because once I start to work from angle y, the opposite should be the 5. So looking at this problem, you'll notice now my 5 is my opposite side, my 5 radical 3 is my adjacent, and my hypotenuse stays the same because that's always the same no matter what. So if you look at my answers over here, you'll recognize the work for sine y and cosine y because they actually switched places with these two because opposite and adjacent switched. Down here, we'll look at tangent y. I had 5 over 5 radical 3. My 5's canceled. Here, I had 1 over radical 3, so I multiplied by that radical over itself, giving me radical 3 over 3. So this is a little variation of what we just did. We are given the value that sine x equals 4/5, and we're going to find the values of the other two trigonometric functions. So when I see this, I can really draw any triangle where the opposite and hypotenuse have a ratio of 4:5. The simplest way is just to draw it with those sides. So I draw my triangle, right angle. I'm going to put my x here to go with my angle. My opposite is 4, and my hypotenuse is 5. So you might recognize this as a Pythagorean triple, but even if you don't, you can always use the Pythagorean theorem to find the missing side. I'm going to use y since I already used x for my angle. So y squared plus 4 squared equals 5 squared. So I have y squared plus 16 equals 25. I'm going to subtract my 16, giving me y squared equals 9. And then I'm going to take a square root, and that's going to give me y equals 3. So this side is 3. Now, as I said, if you recognize the 3, 4, 5 triangle, just go with that. So I already have sine of x. I'm going to find cosine of x and tangent of x. Cosine of x, we'll label our sides, opposite, hypotenuse, adjacent, right? Opposite x is O. So we have for cosine, adjacent over hypotenuse is 3/5. And for tangent of x, we have 4 over 3, opposite over adjacent. This is a good time to mention that whenever we do sine or cosine, we always have to attach it to an angle, or sine, cosine, or tangent. We can't just have cosine equals 3/5 because cosine is always in reference to some sort of angle that's in the triangle. Why don't you try the next one? This will involve radicals. I'm going to have the work up and we'll talk through it. So I'm going to pause the video now and go ahead and try part B. So I'm just going to step through this process. You can check your answers there over here. Basically, I drew my triangle with opposite and adjacent labeled. I did the Pythagorean theorem. Radical 85 does not simplify. There are no perfect squares that go into 85, so I just put that radical 85 on my hypotenuse. From there, I labeled my sides. So you'll see from angle T, opposite, adjacent, hypotenuse. I set up my ratios for sine t and cosine of t. Both of them have a radical in the denominator, so I had to multiply by radical 85 over itself in both cases, and then I ended up with these lovely answers on the side, 6 radical 85 over 85 and 7 radical 85 over 85. So the next thing we're going to do is we're going to add on the trig reciprocal functions. Now, the biggest thing you need to remember is this is going to seem like, oh, now I have double to remember. It's really just information that's connected to what you already know. So I'm going to zoom in just a little bit. Hopefully that's straight. So the 3 names of our new functions are cosecant, secant, and cotangent. So cosecant has an abbreviation of CSC. Secant has an abbreviation of SEC. And cotangent has an abbreviation of COT. But still, when you see these abbreviations, like you don't say the word cot for this, you would still say cotangent, just like we don't say sin for sine. So the ratio of the sides of a right triangle, cosecant is hypotenuse over opposite. So when we look at this, the relationship, this has a relationship with sine, right? Because sine is opposite over hypotenuse. So cosecant is equal to 1 over the sine of the angle. And I guess I should put an x over here because each of these need to go with an angle as well. So secant is hypotenuse over adjacent, which is 1 over cosine of x, right? Because that has the adjacent and hypotenuse in it. Cotangent is adjacent over opposite, so that one goes as 1 over tangent of x. So one of the things that isn't so great, you might want cosecant to go with cosine, but it doesn't. Cosecant goes with sine, and then secant goes with cosine. So they're kind of opposite because they have different starting letters, but it's something you can deal with, and it's just something you kind of have to memorize. So we're going to see these values with respect to angle A. So when we look at these from angle A, this is opposite, it's the hypotenuse, and that's the adjacent side. Since cosecant is hypotenuse over opposite, that ratio would be 13 over 5 because 13 is the hypotenuse and 5 is the opposite side. Secant of x, or secant of A in this case, right, because we're working from angle A, is 13 over 12, hypotenuse over adjacent. And then lastly, cotangent, adjacent over opposite, is 12 over 5. So you can look back at this page, but we're going to do some practice on the next page.